people think storage has to be a certain way, and they think the horse carriage worked for the past 20 years, so this is the right way. And then you have new workloads in the enterprise, like machine learning, and then they don't understand why the users are like, this doesn't help me, I need a race car.
Hey friends, this is Podcast Ruined by a Software Engineer. I'm Perry Tiu, and on this episode I get to talk to Björn Kolbeck, co-founder and CEO of Quobyte. Quobyte is a scalable and distributed file system that can be installed on your servers in minutes. If you enjoy Podcast Ruined by a Software Engineer, don't forget to hit the follow button on your podcast app so you don't miss out on the new episodes. And you can pick up podcast merch at perrytiu.com/shop. Enjoy the episode. Welcome back to another episode of Podcast Ruined by a Software Engineer. I'm your host, Perry, and with me today is Björn Kolbeck, CEO and co-founder of Quobyte. Björn, how are you?
I'm good. Happy to be here.
We're happy to have you on the show just because people know we talk about tech on this show, but your extensiveness of understanding tech, you have a PhD in comp sci, so this is a topic that I definitely want to talk to you about. But more importantly, talking about Quobyte, it's a product that is very technical, but also at some point understandable because we use file systems every day. Everybody who uses a computer uses a file system. So those are stuff that I feel like it's so relatable, but so much expertise behind it. So I just want to say thank you again for being on the show. You know, to make this as simple as possible, who is Björn and what is Quobyte? With your words, maybe like a 30-second.
I would say I'm a software developer at heart. I always wanted to be a software developer. Did that, and then when I started Quobyte with Felix, I basically had to turn into a CEO and learn more about, the business side. How do you run a company? How does sales work? How does marketing work in a competitive market? All of those things. So I would say at heart, I'm still a coder, but I had to switch careers. And when it comes to Quobyte, you mentioned file systems are everywhere. A lot of applications nowadays have a lot of data. I come from the HPC world, high performance computing. But now enterprises run workloads like machine learning, analytics, and so on. And everyone deals now with petabytes, 10 years ago, a petabyte was a lot of data. Now we're talking about tens to hundreds of petabytes. And you need file systems that can store this amount of data. And that's basically Quobyte. We make it really easy to have large-scale data and also use it.
Yeah, and I can imagine the complexity and the algorithms behind it. And we're going to dive into that in just a second. But something that usually helps me to understand a lot of this is when you're mentioning deciding between doing more tech, coder, like at heart kind of thing, but also doing this business side, the question I usually have for people is like, did you always have that? Did you always have these ability to take your technical side and bring it into the business side to it and vice versa, right? Because there's a lot of you have to do both. So maybe if we start a little bit earlier in terms of, I guess, like childhood. Influences in childhood. What did your environment look like? Like, where did you grow up, and was it kind of techie around you? Did you have like different kind of robotics around you? Like, what did that look like at the beginning?
Yeah, I grew up in Berlin, and my environment was not very techie, I would say. My father worked for a bank. My mom worked for a clerk for a company. So typical office jobs. But I was always interested in technology. I got my hands on a typewriter, old typewriter that my mom brought home. And the first thing I did was take it apart because I wanted to know how it works. So I think that, I always loved taking things apart. Putting them back together was a bit harder. But I wouldn't say my environment was necessarily techie. But I was always interested in tech. And then when I got my first computer, it was basically, I was done. I think it was like 10 or 11. When my dad bought me a Macintosh SE, great computer. And that's how it started. I wanted to know, what can you do with it? Not just use it, but that's how I got into programming. There was this application called HyperCard. And then, you stumble upon it as a kid. You try to figure out that you can program stuff. And that's how I got into programming. It was a bit bumpy, the road into programming, because I didn't know anyone who was a programmer or who was good with computers. My friends, their parents were, I think one of them was a computer enthusiast, but not really a programmer. So basically went to the library, got books about programming, and that way I learned then Pascal. It was interesting, but I always enjoyed it. And I think that's when I decided that I want to be a software developer.
There's a couple of things I could highlight here for sure, in the sense of like when you're saying of growing up with having access to like a computer and everything, like even if I talk about my childhood a little bit, is like we have access to a computer, but the next level after that, other than like games, other than writing text and other than that, is like the next level of like making computer programs. And that's always been a barrier that's been kind of hard, even as a kid, right? Between 10, 11, 12, 13, 14, 15. It's always that barrier to be like, yeah, am I alone in this adventure? Even me as a kid to be like, I didn't obviously program that much as a kid, but thinking about it to be like, all my friends know what's a video game. All my friends
Yep.
know what to watch videos. But that next barrier, I really like the perspective that you just threw out there in terms of, oh, that's a specific part of your journey that kind of led you. I mean, it's related to what you do today. I want to double click real quickly. If I could ask this, I've heard HyperCard a couple of times. I have not used it. I want to take the moment to be a learning lesson for Perry and maybe for others to be like, what is HyperCard? It's a program that you double click and it opens and then it's a text editor and then you can press run. Because I'm assuming a lot of IDEs, that's kind of what they look like nowadays, but I feel like it's not.
No, it's not. It is this weird application that came with Macintosh or with Apple's operating system in the 80s and 90s. And I think the best way to describe it is like it was like a web browser on your local machine, so not connected. The idea was that you had cards, which were like pages, screen sized. You could navigate between the cards. And then you could use a scripting language to modify things. You know, there were buttons, text fields, you could move things, you could draw. So in the end, it was like, yeah, a basic version of a local web browser. And I think this is, I might be wrong, but I'm pretty sure that Tim Berners-Lee mentioned HyperCard as an inspiration. Someone that worked on the web mentioned that as inspiration. And you had the ability to click on text and then go to another page. So in the end, yeah, it was like a very early web browser without web, same concept. And then it had HyperTalk, a scripting language that was very simple, that later became Apple Talk or Apple Script, I think. And then Apple discontinued it at some point, but it was very easy to get into because the entry barrier to doing simple things wasn't high. So it was perfect for a kid that you didn't know a lot about programming just to get started, and it was graphical, so you had a user interface.
That's amazing in the sense of like, you know how nowadays there's like these iPad apps or there's like these phone apps that's like it's graphical, right? You have like a bit of on the left hand side like these lines of code that you can modify, and on the right hand side it'll be some like some animations of a little user just jumping a little blob jumping left and right kind of thing. So I feel like that what you describe as HyperCard, it felt so similar to me, where you have a little bit of access of this middle layer of understandable code that people could render and parse. Did you know if it ended up compiling to like C behind the scenes, or what exactly happened? Would you know? I mean, it's very complex, but
it didn't compile. I think it's really you created a file that was a stack that had everything in it. I think honestly the best comparison is a web page with JavaScript, which is more complex, but it's like, nowadays the kids have Scratch, which is a graphical environment where it's easy to gather the concept and modify visuals, which is always exciting. When you have this printf hello world, it's like, I think the barrier to that is higher. So HyperCard was great to get into it, and just like Scratch, the barrier to get started and see something happening is very low. I think it's a great way for kids to get into the programming.
no, absolutely. That I was gonna say the word gateway as well, and I was like, I think it really does expresses that idea of like give a kid a tool and let them run wild, and this is how the beginning of a story kind of becomes. And shout out to HyperTalk. I was looking into some files about AppleScript before, so the fact that you mentioned it might be the ancestor of AppleScript is very fascinating. This was literally just a couple days ago. I was looking at something about that, so super fun things to learn about. I want to go back into the fact that you get exposed to this stuff like 10, 11, like a age where you get to absorb so much information and you get to apply to it. Was it useful, that information, going into school? Did you ever bring it with you to like high school in terms of, I'm able to practice this? Just because I know sometimes if I learn something cool on the internet, I don't get to use it when I was in high school, for example. So did you go into a lot of sciences and computing before university, or was it just the typical, I guess, like, hey, we're just studying history, sciences, biology, and physics going into that? What did that look like after?
Yeah, computers and computer science was not really part of the high school curriculum in Germany back then. I think we had like a class in ninth grade where we learned how to use Microsoft Word for DOS on ancient computers. And then I think my last year of high school, 12th or 13th grade, was when they had a computer science course that I took. But the problem was that, I basically had to do it at home. I had one friend who also programmed a bit, and then you learn more. I switched from Pascal to C++, learned about object-oriented programming. You get a lot of information. Back then it was libraries because internet was horribly expensive to dial up. AOL, you paid them by the minute. So by the time I had this class in high school, I think I knew everything already there. That was like, I don't learn anything new. And they didn't really focus a lot on the theory behind it. So it was very boring. I remember one time when we had the written exam, I looked at it and I was like, okay. 10 minutes, handed it in. The teacher asked me, is something wrong with you? I said, no, I'm done. He was speechless. And I'm like, yeah, okay, I've done that for some time. So school was disappointing, I would say. It was always like, I didn't have, the influences to learn more than what I got from, programming books. But that changed rapidly when I started studying computer science at the Technical University in Berlin.
No, that's great. I think the comparison is the kid that just learned how to play guitar with either from family members and everything, and they go into music class and they just absolutely shred all the notes. Kind of a bit of similarity, but I think as you were saying, that kind of propels you. It's like some baggage, some fuel that you bring with you to the next stage, next level, because life eventually goes on. So even understanding a bit of maybe the culture in Berlin, knowing the fact that, hey, not every city, not every country is very tech forward from the get-go, right? Some countries would be everybody has to do this learning how to code at grade 9, for example. Some countries, nowadays probably it's more common, but back then you could see the difference on that. So it's really cool to see your perspective on the different culture behind it. But I can agree with you in the sense of going into the bigger leagues, right? Going from high school to university, that's when you're comp sci. Is it only about writing for loops? It's not. It's more than understanding how to write a for or while loop, whatever. So, when did you make the decision that comp sci was the degree that you wanted to? I asked this question just because I know everybody has a different story. My story is that I got into university in physiology and math. It was a double major. It was something about biology, organic chem, a lot of fun stuff. I did not enjoy it after 6 months. I knew after first semester I did not enjoy it. So next thing you know, Portal dropped down, you see all the other majors, and comp sci showed up, and I was like, that sounds kind of cool. So next thing, I geared all my classes toward comp sci. So this is a very quick story of how Perry decided, in quotation marks, comp sci. But maybe from your end, were you convinced? You were like, I know I'm going to go into comp sci from the get-go. What did that look like?
Yeah, I think that I was really lucky because, as I said, when I was, as I got my first computer and got into programming, it was always 100% clear to me that I wanted to be a software developer. So, after finishing high school, it was absolutely clear that I need to study computer science. Because, what do you do if you want to become a programmer, you study computer science, full stop. So there weren't really other ideas. I think my mom always wanted me to study something more solid. She wanted me to study physics. As I said, Germany in general is not how do I say that in a nice way? Technology, internet, computers are still, I think to this day, regarded as something novel. So back then, computer science is that a real thing? Can you make money? Blah, blah, blah. I took just to see what it's like, I took a semester of the physics lab classes where you basically watch a pendulum 100 times and time it and those kind of things, and decided that never ever do I want to do this. I'm not a hands-on person. I like computer science because it's theoretical and we work with computers, and the electrical engineers have to figure out all the nasty stuff about the processors and the motherboards and stuff. I want to deal with computers programming bits and bytes where you can change things, within seconds. So it was it was never a question. It was I had to do the, after high school, Germany, you have to do military service, or I did social service instead at a hospital, did that for a year. Great learning experience that told me again that, I definitely want a university degree. And then it was computer science.
you said it with so much conviction. I'm jealous. I keep on saying that a lot of people going into university and going into life in general is like, what is this? What am I being offered? Psychology, social like studies, and then you have engineering, civil engineering on one side. But the fact that you made some connection that made you be like, computers, software, hardware, there's so much to think about it, throwing the bits left and right. This is something that I actually do admire from you and a lot of people who have this understanding at a young age at that point. But then when we talk about school and talk about education and everything and comp sci, I can relate to you because fortunately I did comp sci, but in Canada. And as you were saying, like this, treating comp sci or treating technology or computers as like the devil, like there is a sentiment. Like at least like my parents did think about like, my parents are very pro technology actually, but I think the community behind them, like around them, sometimes it'll be like, wait, technology, like is it going to take over a world? Like kids are going to get so lazy because they're going to be so focused on touching computers and not never going outside and everything. I do understand the sentiment that you're talking about, reluctancy on it, but one thing I want to find a bit of relatability with you at the moment is my comp sci degree was like, first you learn Java, and then sometimes you learn more like algorithms, and then you learn more like data structures, and you do a bit of like computer vision. I did that a little bit actually, but that was a graduate course. So maybe for your, I guess, like undergrad, which is before your master's, was it fairly standard, or was it your expectation actually? Because you already had an understanding of what a bit of programming is. Was going into that first university, actually, where was it at?
It was the Technical University in Berlin. The TU Berlin.
TU Berlin. Sure. That's how the cool kids say it, so I'm gonna say it like that. At TU Berlin, was when you got into there, was it your expectation basically, or was it really just every time you showed up to a class was something completely new and you were just like, wait, I know nothing about computer science?
I think it was the latter. In Germany they don't call it computer science because they call it informatics. That's a translation because they didn't want to make the science of computers, but the science of information processing. A long theoretical story, but basically your undergrad starts with a lot of theory. So all the theory around algorithms, complexity, all the stuff I already forgot. But that's where I basically learned that I know nothing. That's why suddenly you get the foundation. In Germany, the idea back then was that everyone does their master's degree, so 5-year program. So the first 2 years is a lot of theory. And that was, it was shocking in a way because I wasn't prepared for that. As I mentioned, in high school, we didn't really cover the theoretical part. But it was also exciting because suddenly a lot of stuff made so much more sense. When you have the theoretical foundation, you start to understand how programming languages are built with the Turing machine, the theoretical background that everything is built on. And suddenly it's like, okay, now it makes sense. It was, I had a hard time, I would say, the first semester. You come from high school, you go to university where you're on your own, not a lot of structure, and you have to learn a lot of new stuff in a very short time frame. So that was tough. And there were probably times where I thought, like, is it really worth it?
No, I'm glad you share this because a lot of people think about the same way. But once you throw out those words of like the currying and like everything that is behind all these like the directed asynchronous acyclic graphs, like all these terms that like I'm sure a lot of people that have done comp sci relate to is so fascinating that I feel like I should have enjoyed it way more back then. But maybe from, as you were saying, like the perspective of I don't know anything. Why am I so like stressed out about this? It's really, really cool to be able to share this with you. But one thing I do like asking people who did comp sci at the end is, I know if you had an equivalent of a capstone project. It's basically like a year-long project where you get to, I guess, apply. Because some people don't like this about university and some people enjoy is that it's very theoretical and you don't always get the chance to apply it into a real application, to a real something you build. So I think I was quite fortunate. In Montreal, that's where I'm from and that's where I went to university at McGill. It's pretty a game-heavy city, basically, like the Ubisoft Montreal, all the Square Enix, like the cool stuff out there. Our capstone was basically, here's Unity, learn how to do C# and make a board game kind of thing. And we spent a year doing that. The first 6 months is blueprinting, and then the next 6 months is execute it and build it. And it was really fun because you generate tiles and you generate different like maps and everything. So at least that's my capstone experience of using that technology, that understanding that I learned. I'm not in the gaming industry today, so I don't know what it was for, but it's really cool. But from your end, did you have any opportunities to do anything similar, a capstone project, anything like that?
Yeah, I think there are two projects that stand out. So everyone had to do, I think we had to do 2 6-month projects. And I decided to do neural networks. Back then, yeah, it's fascinating because the math behind it is highly complex, and I forgot almost all of it. The backpropagation, but we had to implement it from scratch in C++, I think. A neural network that we trained then to do with Fourier transformation, recognize vowels, from speech. That was amazing. It was a tough project because we only had 6 months. We worked in a group, and we had to really. I think the only thing we were allowed to use was a library for Fourier transformation. Everything else we had to program, and the debugging. Oh my God. So that was amazing. And nowadays, when you look at everyone talks about deep learning, it's like, yeah, this is interesting. I remember this. The theory is still almost the same as 15 years ago. But the bigger project was my master's thesis. So you do master's thesis that can take anywhere between 6 months to a year. And you have to basically pick a topic, find a supervisor. And I was kind of lucky because I worked at another university in Berlin, the Free University, FU, in the chemistry department. They hired me as a sysadmin, to run their computing cluster because they did a lot of modeling, theoretical chemistry, protein structure alignment, so on. And so I worked there with biochemists and chemists in a team, and I was able to do that project as my diploma or master's thesis, which was using genetic algorithms for 3D protein structure alignment.
No way. Is it the similar vein as recently when talking about Google DeepMind using like the protein folding? Is it in the same lane?
Yeah, exactly. So it's the holy grail of bioinformatics or protein structure or protein folding prediction. When you have the sequence of a protein, like the amino acids, how does the 3D structure look like? Because interestingly, the same sequence always folds into the same 3D structure, and you can basically pull them apart, and they all spring back into the same structure. And that structure most likely defines the function. Like, does it bind to certain receptors in your body? Does it bind as an antibody? Blah blah blah. As a computer scientist, I have a very highly simplified view of this. But yeah, Google solved this problem with their machine learning, and that was a tough problem. And it was everyone was working on it, and suddenly it became a reality. They solved it, so now you can predict it. But back then, we were looking at ways to do that. Another colleague was working on support vector machines for binding prediction, and we tried to map proteins as a graph. You have the helices and what they call beta sheets, where it's like back and forth, very stable structures, and we try to represent that as graphs, and then use genetic algorithms to find matches. So basically, you put in the sequence, we find something similar, and then say, okay, this is what it might look like. Yeah, that was a very fun project.
No, absolutely. The way you describe this is so fun, and people don't see this as audio only, but I'm like nodding my head. I'm like, yeah, I know what you're talking about. I did organic 1, and like that's the extent of what I know about. Like, I remember like the molecules and the edges, and like the you have to like vertex, and you have to like the structure. I think it's like a physics thing where they have to have the structure, or else like it's just not that element at the end. Anyways, like I'm not gonna dive super deep into that because I'm literally the worst person to talk about this, but.
It's the same for me, as I said, as a computer scientist, you try to turn into something you understand, a graph problem.
Yeah, basically. Our lives are basically just graphs, and we're going to talk about that in just a second in terms of maybe that also might explain a bit of Quobyte, but one thing that is obviously eventually, something that is that I keep on saying it's really cool is going from a master's into a PhD program that is relevant to what you're doing that is directly. Because I know some people, for example, if Perry, if I wanted to do more extensive study, I would always consider maybe I could just do like an MBA, or maybe I could just do something in finance, or maybe something else in a completely different direction. But your story is a great story because you took all of that and you channeled it into a PhD program. So was there a specific thesis you knew already going into your PhD program that you wanted to dive deeper into, or was it more like got into the program and then you explore what's your thesis after? What did that look like?
It was I was so after finishing my master's degree, I was looking for the jobs as a programmer or computer science jobs. And kind of, Google was very cool at that time. And the jobs were mostly like, oh yeah, you can, you write data programs for databases and, typical business applications. Like there must be more. And then I got in contact with the person that ran the project at the institute where I did my PhD later on. So that institute it's called the Zuse Institute. They basically have the computer science division there has two parts. One is they run a supercomputer for northern Germany. So it's basically a HPC center. And the other part is that they did research. I said past tense because my supervisor retired. So I don't know if they still do that. But he had a research group for computer science research in distributed systems. And back then, 2006, distributed systems were a hot topic. It was like, everyone was looking at Google's infrastructure. Google published a lot of papers. And the interesting thing was that Google built the entire infrastructure basically in software on regular servers. No more specialized hardware and so on. And they demonstrated how to do that at a massive scale. In the heart of that, the theory behind it is distributed systems. So here was an opportunity to do a PhD in distributed systems. So back to real computer science. And then I met my future co-founder, Felix, because he was already there as a PhD student working on the project, looking for new researchers, PhD students to join. And it was a big European research project called ExtremeOS for research. I think back then the goal was to find or to develop Linux for grid computing. So the idea of distributed scientific computing. And that's how I got into it. It sounded exciting because, first of all, PhD program, you do research in something that I really wanted to know more about. It was what they call in Germany a full position. So you basically get paid a decent salary as a researcher. I think that's, in the US, you have to pay to get your PhD. In Germany, you don't have to pay for it. And then as a researcher, you get money. So it's actually a bit more attractive. And so I basically joined them and worked with Felix in that project. So that's how I got into it. I think it was like, I wanted another challenge. I wanted, not working on standard business problems. I wanted to do something exciting.
No, definitely. And I think I agree with you, by the way. Just people will bash Perry, but like coding, there's some appeal to it. But building your own project and your dream and researching, there's always something more fun about it. But this is really cool. I keep on using even the word really cool for me. What it means by that is that everything, all the bricks kept on laying as you were building stuff, right? All the train tracks were building in front of you as you were going through all of this, right? You kept on seeing that, like, oh, this, if you go into here, you could like build this thing that is relevant for the distributed system world. And even the fact that the emphasis that you're putting of relying on software over hardware, just because when we're talking about if you want to scale it, running a program 1,000,000 times is a lot easier than like trying to get 100 more machines to do different other things. So I think this is one of the cool emphasis that you just mentioned over there. And maybe just to help the viewers, the audience a bit real quickly, is that you did do a stint at Google. I did have a couple of previous guests that have worked at Google as well at different times, of course. And I always want to take the opportunity always to maybe just ask you in terms of how did you get exposed to that opportunity? Was it during your studies that you got like an internship, or was it straight out of your master's degree, if I got that correctly? They offered you a position there. Like, what's the introduction there? Just because I know it had an impact in terms of how you think about the world and how the part of software is everything. That kind of attitude a little bit is really cool. So maybe your little, tangent on your story into Google.
Yeah. Actually, Felix and I both did internships at Google when we were PhD students. Felix was first. I don't remember how he got introduced to this program. But he definitely did an internship at Google Zurich. And then I think he came back, and half a year later I applied, interview process, blah, blah, blah. Got the internship. So basically, so I worked with a group there that worked on Safe Search. and they gave me a project like, here, write something that, we need a tool that checks URLs for whatever. So I was able to build something from scratch. And that's like, this is where coders get excited, because maintaining code or extending something that's existing is always, I would say, less fun than building something from scratch. So you had the opportunity to churn out something from scratch. So I within a short time, I basically put up a prototype with web interface. So I got into web programming as a student, as a side gig to make money, because it was good money back then. So it was like, web interface, building that backend, C++, putting that together very quickly. That was a lot of fun. And then, because I got that project done very quickly, I had a lot of opportunities to look into different parts of the infrastructure and learn more. So I got my C++ readability, which basically means that you are allowed to do code reviews in a language. Got that as an intern. That was a lot of fun. And then I had to go back. Then I did so-called conversion interviews. If after your internship, they want to keep you, you still have to go through an interview process. Did that on site, and then got the offer, went back to Berlin, finished my PhD. I think my daughter was like 3 or 4 at the time. Now she was 3, so she was young. So wrangled all of that, got my PhD done, somehow finished the writing of the thesis, handed it in, and then moved to Switzerland, and then went back to do the defense talk for my thesis. So it was a bit of, well, when you get the chance to work for Google, you don't say no.
That's so good as a story, because of course, when you're talking about all the stuff behind the scenes, right? Like, that was happening. There was these internships, there was the family, and there was living in different situations, and there was these opportunities that we were mentioning in terms of like, maybe I could touch the infra, maybe I could touch more than that. It's so fun in the sense of, I like to think about, did your first project ever made it to production? Because I feel like a lot of internship experience, that's always a question where, did the first thing you built that, did it ever make it to prod?
Yeah, it made it into production. So yeah, I think that's the most exciting part. When you get to build something from scratch, there's a problem. You take it apart, you figure out how to solve it, you implement it, you bring it into production, you see people use it. That's, for me, that is always the most satisfying part, where you feel like you have a product. Like an artist, you put something together that then becomes visible. And I think, honestly, today, that's still one of the most satisfying parts of my job, that I get to see customers that use our product, and it's just, their business relies on our product. And that's just, I sit there sometimes and think, okay, I wrote this part.
I love it. And of course, the more mature you get, the more you think about like, okay, fine, I have to deal with the customer feedback and like the client feedback and the user feedback. That's like, that's a different part of like just throwing stuff out there and making it work. But I'm gonna take this last opportunity to ask about before we get into Quobyte, because I'm gonna get into that because I have a million more questions about that more than anything. Is for me, when I went from school to the corporate world, my workflow as a human, as somebody trying to build stuff, has changed a lot. For example, in school, it was kind of like, okay, figure it out. You have a game to deliver, you have a project to deliver. Figure out your time, figure out what steps you need to do it. You just like right at the last second and just like submit it online, which is usually what every single university student does. But then the comparison I was telling about was when you go into the corporate world, especially in software, there's already a lot of structure. There's already a lot of phase where it's like the BRDs, which is business requirement documents, the PRDs, the project requirement documents, and that feds into the like TDDs, technical design documents, or RFCs as some people call it. And that goes into the code reviews, development and code reviews and PR. So that's a big contrast if you see where I'm going with this. So maybe from your time when you were doing a lot of studies, and I don't know how structured your studies were to begin with, but compared to going into an organization like Google, that even back then, was it like a mature process? Was it a mature software development lifecycle? What did it look like to you when you had these two like different workflows, looking at it on one side academic, on the other side, I guess, like more corporate and more in the private company world?
During my master's program, I did an internship at a large commercial bank in Germany, and the people were very nice, and there was interesting stuff. But that made me realize that the corporate world is not necessarily for me. It was very, very structured, very slow moving, and it was just like I couldn't see myself there. So part of doing a PhD was also this, exactly, you have a lot of freedom. In the end, during that project, we were responsible for data management. We had to produce a prototype, and I'm exaggerating, but basically a PDF report every quarter, but we had total freedom to do, whatever we wanted. And this is how we came up with, we looked into file systems. I had no idea about file systems back then. I didn't know what POSIX was. I didn't know how a distributed file system looked like, what a parallel file system was. So doing this kind of research where you explore things and develop ideas on a larger scale, and then contrasting that with the corporate world, which is super structured, where you have to deliver stuff on a quarterly basis or even monthly basis. I think that helped me or pushed me into the PhD program. And then when it came to Google, I think the difference back then, at least, this was 2010, that Google was structured, but not crazy structured. So it was like, you were supposed to organize yourself. I think they had a huge emphasis on hiring people that were self-starters and that got shit done. So this hands-on approach, there was structure at Google, but it wasn't overbearing. It wasn't like bureaucracy. It was like, we had a product manager. It was a lot of collaboration, talking about ideas. And then, once we had an idea, we just made it happen. One time my colleague said, I like this UI, the different style of UI for our Hotel Finder project. And he just implemented it overnight to show it to everyone. And this kind of approach of, we just get shit done. I think this is what I kept from my Google days, that, you just get it done. You don't ask for permission. You do the right thing. And you try to hire people that know what the right thing is.
Yeah, there's so many words that you said and that resonates with me, because even me going through working on different startups, like I do have this get shit done GSD, like a lot of people throw that out there, is that like when you're doing it, you don't really realize it. But then when you look back, maybe just a little bit, you'd be like, oh yeah, like this, we enjoyed doing this because I keep on saying that modern like big tech companies, they made the software development lifecycle sexy. They made it like enjoyable to look at it, to be like, you could take out the cruft, you could take out the ugly stuff and just keep the fun stuff in it. And somehow people have been working slightly better in engineering world, at least. So that's really, really cool to understand the contrast between both, especially the large banks. I'm not going to dive into that. I've got so many fun stories about large banks and everything, but we'll keep that for another time. But yeah, just to recap, this is so awesome in the sense of like you already had this like seedling of energy from as a young kid in terms of looking at all these like Pascal and all these kind of fun hypercar thing and everything, propelled you into comp sci, and then you did your master's degrees, and you were very fortunate to also do the internship at Google and then the PhD program as well into comp sci, and then you fortunately also took the offer at Google and you worked there for a little bit after your PhD degree. And then I want to get into the seedling of the story of Quobyte, right?
Yeah.
It started somewhere. This is my luxury of asking people, where did your idea start? So maybe if we start with just the name, even like Quobyte, did you come up with it? Did Felix come up with it? And we're gonna talk about how you found it as a team beginning. But the name itself, what is the story behind Quobyte?
So we came up with the name. I think that was like 2 years into starting the company. The original name was Extreme Storage Systems with an XTREM. Like ExtremeFS, because that's where we basically started. But of course, that name wasn't really useful. It was too long and everything. So we had to come up with a new name. There were also trademark things. You want to trademark your name. So we thought about it. So what's at the core? Yeah, quorum algorithms at the core of most of the technology we use. So we decided, okay, let's make this Quobyte. And it somehow stuck.
Oh, that's fun. Because the cool thing about it is that, like, it either comes to you or you go for that name, right? Like, it's usually, like, either you wake up one day and all that. But you did mention that initially it wasn't Quobyte. It was Extreme File System or something similar to that. And this is the part where you're talking about the beginning of this adventure. Because also, congratulations. It's been, almost 11 years since you started this project, this company, this endeavor. It's always something to look at. So, could you tell us a little bit more when how your studies, because I like the fact that you were working on this already during your studies, right? Even after the stint at Google and everything. So Extreme FS, maybe I feel like that's the predecessor of everything. So how did that go from, hey, I'm working at a university into this idea? What did you build out of it, and how did you move it to the next level of, hey, I could run this as a company at the end? And of course, talk to me about the partners. It's always great to hear about that as well.
So it started when Felix hired me as a researcher into this project. And as I mentioned, we were responsible for the data management package. And we were trying to figure out, how do you enable researchers that are distributed across the globe to share their data and also share it in a reliable way and high performance way. In that project, we also had our team from the Barcelona Supercomputing Center and NEC, the high performance computing team from NEC in Stuttgart. And so NEC, the team there was very familiar with the Lustre file system, which is a parallel file system for high performance computing. It's very fast, just not reliable at all, and also not distributed. And so we brainstormed together, how can we do this? And the predominant idea back then was what is called metadata catalogs. Like a database where you find the data and then it has a link to where the data is located and then it copies it over to you via FTP. Some people might remember things like iRods, Global Grid FTP. So that was the standard back then. But we said, no, if you want to make this transparent, there's this interface called the file system that has been around for about 40 years. Everyone knows how to use a file system, how to even scientists that program, they know how to open a file, read and write from it. So file system sounds like the perfect abstraction. So how do we build a file system that hides the complexity of distributed data management? And that's how the ExtremeFS project started. And that for ExtremeFS, we wanted to build a distributed file system that was reliable. So, inspired by things Google did, store data on multiple locations so that when something breaks, commodity hardware, you still have redundancy, that you can, fail things over, that it scales. And so we spent a lot of time researching that. And that also turned into my PhD thesis, how to do the leader election for that. When you have multiple copies, there are different ways of how to keep them in sync. And one is to elect one a primary that decides this is the order in which we do the writes. And how to do that in a scalable way became my PhD thesis, and using a variant of Paxos for that. So the research that we did actually, on one hand, became our PhD topics. And then on the other hand, when we started Quobyte, we took a lot of the ideas from ExtremeFS to implement the product. So Quobyte, you could say, it isn't directly based on ExtremeFS because in research, you need complexity to write papers and publish them. In production, you want the opposite. What we learned at Google. You have to keep it as simple as possible or it will kill you at scale. So we started Quobyte basically with the concepts of and algorithms of ExtremeFS, but rewrote it from scratch. Because one thing we knew we had to build in from the start is simplicity. It's like, there are certain things you cannot put into a software later on, like security. If your software is inherently insecure, you can't put a layer of security on top. It has to be baked into the product. And the same thing with distributed systems. You have to make them simple from the ground up and integrate that into your concepts and how every component works to make sure that when you have clusters with hundreds of nodes, it doesn't kill people with complexity. That's the joke with Lustre. You need an army of PhD students, cheap labor, to keep a Lustre system up and running. So that was what we learned at Google. If you want to make it scale, it has to be highly automated, simple, and predictable.
Yeah, it's so fun because the way you explain this is digestible to me as somebody, like, of course, I have a little bit of background in tech, so the way you describe this, like, complexity versus simplicity is kind of like vice versa in the academic world versus the hey, build software for the mass, basically. That's something that I'll take with me, if anything, from hearing you say this. I also want to, this is a, maybe like a question from Perry is, did anybody ask for this technology of extreme FS back when you were researching it, studying it? Or was it something that you guys saw that, hey, nobody's really looking at this, nobody's really asking for this, but it could serve a thing into it? So how did that, I guess, like, look like in the sense of the motivation? Were you trying to cater to somebody that was already asking for it, or?
Yeah, I mean, the problem of data management and fast, reliable, scalable storage is still, a hot topic. Otherwise, we wouldn't be here as a company. So there was definitely an audience and a problem. So we had a problem and we were looking for a solution, which is always great when you want to start a company around it. For research, research is often the other thing. You find something cool and then you look for the problem you're solving. In this case, it was like, there is a problem, we're solving it, and we're using distributed systems, because I think that was the motivation back then. Distributed systems was a hot topic also in research, so it was a good thing to focus on for research where you could publish, and it was just exciting. And then at the same time, Ceph, the project here in Santa Cruz, was also developed at a university and then into real software, but they took a very different approach. So it was like, we had our corner carved out, so to speak, our different approach.
No, this is cool. Can I describe something, and you can tell me if I'm describing this correct or not, because we're going to talk about Quobyte, the product, and I want to make sure I'm on the right level. So when we talk about file systems, and sometimes people may understand that as like, oh, it's a database for something, right? It's not correct to think about it that way. If you ask Perry of trying to understanding what is a file system, is there's data behind the scenes, and if you open your computer, if you're on a Mac, you open your folders, you open your new folders, and that's a file system because it shows you like the directories, and then it shows you which file, it shows you different file formats. But when you click on a specific file like a txt, that's when it actually gets the data behind the scenes, and that's where you actually get to read the data. But when we're talking about the tool that lets you access all these files and access all these different paths, that is what I assume a file system is. Is Perry correct? Did I get the correct understanding of this? Maybe this UI, this like abstract layer, this layer between data and the user, like Perry using it.
Yeah, I think this is honestly the definition of a file system today. You have this hierarchy of folders, and in Mac, you have they always had the folders. They were the first ones that visualized it. In Windows, you have the backslash, and Linux is the forward slash. But in the end, it's this idea of having hierarchies, and everyone tried to get rid of this. And there was Microsoft tried to build in a database into Windows so that you would just search for your files instead of organizing them in folders. Object storage came along with this. The idea of removing the hierarchies and just having a bucket where you dump in millions of objects. But in the end, the hierarchy just works for humans. It's great for us to work with hierarchies and have a work folder, and then you have projects in there, and you have one folder per project. That's something we can think with, or that works with us. Humans relate to, and they have a representation in the computer. This is why file systems aren't going away, and has been, as I said, an API, so to speak, that has been successful for 40 years. And yeah, it comes with complexities because of the hierarchies and how it works, but people love it. If you look at when object storage first came up and everyone was like, oh, this is scalable, this is the future. I remember the Gartner IDC, they were all like, file systems are dead. Object storage is a thing. And then I think like 2 or 3 years ago, it's suddenly like, oh yeah, most of the unstructured data will be stored in file systems. What happened to the object stores? I think, as you said, hierarchies just work for humans to organize their data. So that is a file system.
one of the best example, the way you describe all of this is I can think of, libraries, they have a very structured way of naming their books, right? They have a certain category and then there's a certain format to it. And you can think about the file system like that, right? In the sense of you kind of give these like category, and the deeper you dive into each category, that's where you're going to find your book at the end. And I think there's a parallel that, at least when we're having this conversation right now, I go back to that example because it's so easy to understand the benefit of doing it that way. As a random life hack, if you want to know, is every time I make a new folder, I start listing as 000, like 0, and then the next folder, like you do 000, and then underscore, and then give it like a category name. And then the next folder that I have in the same folder, I just do 00001 underscore that file. And all my files and folders are like that. So, hey, maybe that's a random tangent that people might pick up at some point.
I'm always impressed when I see people that really are very structured and have a very nice folder structure with year and stuff like that. Because I can tell you, I will never show you my folder structure on my Mac, but all the nice things I said about file systems and structuring and order and tidiness does not apply to my file system.
Yeah, that's so funny. Well, you make it sound that I'm very structured. I'm not, trust me. It's just that one example that I will take that win if I can. And the other interesting part that when you're talking about Quobyte and talk about this distributed part to it is, as it on a layman level for Perry at least, the distributed terms mean that the data, no, not the data. This is a good question to ask you, if anything, is that which part of the file system, which part of the data, like which part of this is the distributed part? And for maybe my understanding, distributed just means that it's located in multiple different machines or multiple different, I guess, clients or servers or however you want to call them. So, yeah, I'm genuinely curious. I don't care if the audience wants to hear the answer or not. I just want to ask this question because it's such a fun thing to think about.
So the short answer is everything. Because, part of distributed systems is that you have multiple copies of everything and that the failure of a single machine can be tolerated. Because you don't, that's how you get fault tolerance. If you have a single point of failure, it sucks. And I think it was Lamport who said, a distributed system is one where I can't work because a computer that I've never heard of is unavailable or something like that. I'm paraphrasing here. So part of Quobyte and most modern distributed systems is to distribute in terms of, scaling out, so aggregating the performance of many computers. So that's the scale up versus scale out, because, CPUs go only faster so much. And I think we're done with that part more or less. But if you can scale out, so if you can grow a system by adding servers and capacity to have a bigger and bigger file system, or if you can, do the compute in a way where you can run your job on 1,000 compute nodes and aggregate the performance, then you have a system that can scale. That's one part of distributed. And then the other part is the reliability. Distributing or replicating data or having data and state redundant across machines so that you can tolerate loss of hardware. Because that's where the old approach was, let's build hardware that's super reliable. Right, so you try to build redundancy in hardware, dual controller. They are in the same basically computer, in the same box, and if one fails, the other one notices that and then can fail over. But there is a limit to how big those systems can go, and they also make the hardware very expensive. So the approach of distributed systems is to do it in software across machines communicating over an unreliable network.
That's really great. I think the best way for me to understand this is we're going to talk about your audience, as in your target audience, in the sense of you're building a product and you're building it for somebody to use at the end. So we're going to talk about that in just a second. And for me to understand this distributed file system is understanding that I could have the structure, these file structures, these like going into these different, I guess, like categories of topics, files, whatever you want to call it. And then I could see the same structure everywhere that I want to use it, basically. I'm assuming it's on the cloud and you could access it to different parts whenever you need it. That's at least what I'm assuming. When we talk about distributed, it eventually goes to the part of, hey, it's copied, it's mirrored everywhere, that, hey, it doesn't have to be my machine. My machine could literally burn on fire right now, and it should be totally fine. Is that good to think about it that way, or is it not the same category?
That's another category. That's what we call shared file system. So this is the part where your clients, the machines where you access a file system, local file system is easy. That's your laptop computer. You see it, you can modify it locally. Another user could do it on the same machine, but not outside. Shared file system is, the classic example is you start an NFS server on your Linux machine, And then you can mount or access the file system from many clients. So that's what typically you think of. But then you have the NFS server, that's one server. So everyone is talking to that server. And if you think about HPC environments, we're talking about thousands of nodes, thousands of clients talking to one server. That server is a bottleneck. So you want to scale it out, make sure they talk to many servers. And then the one server is also a single point of failure. If that one goes down, no one can work. So you want to make sure that the data is replicated. So if something breaks. So that's basically the shared file system part from the user visible side, and then how you implement it, single server versus scale out versus reliable.
I'm glad I asked that question, because there's a lot of these stuff where it's like I feel like I know it, but I really don't, and this is a lot of stuff that you end up having to clarify. So thank you so much for that. Going back to the audience, the users, the people that you build this product for, what does a typical user look like? Is it a developer? Is it somebody who's just interested into having, I guess, a really cool file system on their own product? Like, yeah, could you describe that?
I think most of our users are more in the IT department. They run the infrastructure for their internal customers, for the internal users. Because, I would say our target audience has a petabyte plus, often tens of petabytes. That's a lot of data and also a lot of expensive hardware. That's nothing you have, lying around at home. We have a free edition that you can download and use that has all the abilities. So if you have 4 servers at home, you can use it. But I think that's a small subset of enthusiasts. Most people don't have that. So it's enterprise users. And then often the people that have to deal with the storage is the IT department. And then sometimes, unfortunately, the IT department still thinks in terms of VMs and LUNs and block devices. And on the other hand, you have then the users, like the data scientists, that try to do machine learning, and they need scale out high performance storage. So there's a bit of a transition for corporate IT. But in the end, those are usually our target. And sometimes the users do it themselves because it's so easy, because they can't get from central IT what they need. And then they just do it themselves. But I think the better way is if the IT people whose job it is to provide good infrastructure, if they run our software.
No, that's really cool. And you were mentioning in terms of run our software, because this is fully software based. Going back to the idea that like this you could distribute this way quicker than an actual hardware product and everything. So is that the intent that maybe you could describe how a user starts with Quobyte then? Like I'm starting at 0. I work for a certain IT department at some company. I'm starting at 0. There's this software that behind all the complexity, it's still very user friendly. Where do I start, basically?
So assuming you have Linux servers, simple servers that have hard drives and or flash drives in them, you put a regular Linux on it, like CentOS is dead, Rocky Linux or Debian, whatever you prefer. And then you can download our software. So basically, I mentioned the free edition that we have. That's the starting point. You run the installer, and that starts the software, and then takes about 10 minutes, and you have a cluster that's basically ready to scale, fully fault tolerant. That's what we mean with the simplicity. The status quo in storage is still that companies sell you appliances, so specialized hardware instead of standard servers. So it means you have to buy the specialized hardware from them that only works with them. You have to learn how to use that. Usually it's also overpriced because it's specialized hardware. And our contrast is a download, real software storage. So that was always something that we wanted to do, because then the hardware is simple. Everyone knows how to manage a Linux server. Right? Everyone in IT knows how to do that. So if you can do that, you can install our software. You don't need to learn things like kernel modules, how to compile stuff. We kept it really simple. Installation, all in user space, very easy. Because that, if you can do it yourself, the installation, management at 4 nodes, and of course it's also easy to do that at 100 or 200 nodes in a cluster. So the simplicity, that's what I meant. From the start, from the beginning, we put simplicity first. And that's why we can put it out there as a download and don't have to hide it and tell people, yeah, we will come on site to do the installation for you and it will take you. No, here's the software. In databases, it's pretty normal. You download MySQL or, I don't know, Redis or whatever. You download it, install it, run it. Storage shouldn't be different, but somehow the whole storage industry is still stuck in the past, where they think it's this like black magic where we need special hardware. My favorite, it's a bit of an oversimplification, but Yahoo built their infrastructure on storage filers from a popular storage company that was also based in Sunnyvale. I won't name them. But, traditional storage hardware, very expensive. Google decided to build their own scale-out file system that runs on commodity hardware. And we know how that ended.
That is such a good understanding that, hey, there are better solutions. You don't always have to take very old technologies and keep on trying to making the fastest horse possible, right? Back then compared to, hey, why don't we just build a new car, basically? This is kind of something that kind of just throws it to my mind in terms of, hey, you can find a better way of tackling a lot of this, so...
Oh, that's actually a great analogy with the horse carriage versus car, because that is sometimes the problem we have, that people think storage has to be a certain way, and they think the horse carriage worked for the past 20 years, so this is the right way. And then you have new workloads in the enterprise, like machine learning, has crazy requirements for storage, and they're trying, central IT that says, oh, we have this beautiful horse carriage, and then they don't understand why the users are like, this doesn't help me, I need a race car.
Basically, I'm not going to take credit for that analogy. That's always been like the Ford model, where it's like, hey, we could always build a faster horse. Anyways, but that is really cool to think about, because I want to take also this opportunity to talk about, how you have all these like distributions that you could start with like on a Linux machine, but then you can also do it through Docker and through Kubernetes and through Google Cloud. These are very modern technology, and this integration adaptation of it. So maybe like a 2-part question is the first part. This is a tech podcast. Like, what did you use to build Quobyte? Maybe like a language, whatever you could share, in the sense of like, did you take your past experience as like, let's do it in C++, or did you adventure into, hey, there's a cool community of Rust people that can build stuff, or maybe even from back then, we're a C shop, we're going to stick with C, like, what can you tell about how is Quobyte built at the moment? Because I like to geek out about this stuff.
Yeah, Rust wasn't really around when we started. And when we started ExtremeFS, there was this idea of how do you build software that can handle high throughput. So it was like multi-threading versus actor-based. Lots of discussions there. I think that one has been solved, but we decided to build it in a mix of Java and C++. C++ for everything that needs performance, and then Java for distributed algorithms. And the reasoning behind that is that when you build distributed algorithms or implement the algorithms for distributed systems, you're dealing with highly complex code. Taking advantage of stuff like garbage collection and so on made the development cycle much faster. So today, it's a mix of the two. And then, of course, client side, because you're interacting with the Linux kernel, that is also C++.
Oh, that's so cool, in the sense of, I do understand when you're talking about, hey, we know how to leverage certain languages for their features versus other languages, the garbage collection. I'm assuming that Java threads are very useful in some cases more than other stuff as well. So there's a lot of these, like, I guess, choices that you get to make when building a product like that. It's so fun because it's so complex. I'm kind of geeking out way too much about this, but
we never wanted to use a language just because it's cool. Back then, when we started the Rave, was all Scala and Erlang. I don't know if you remember Erlang. It was this weird functional language that was developed, I think, with Ericsson, focused on reliability. But then when you start a company, you have to think about talent pool. Do I get developers for this? Performance. Can I make it fast? Or, this is not a prototype or an exercise anymore. I have to create a product that needs to be fast and reliable. And so there are certain aspects that come into this. And Java is extremely mature.
Yeah, I could totally understand looking back and then moving forward, how you make the decisions of how it shapes a product. There's so many, I guess, time. I'm sure you spent so much time thinking about this stuff. So it's really cool to just see it in action at the moment. I want to come back to Bjorn real quickly. We spoke a lot about Quobyte, and I want to talk about your role today. Do you still code? Do you still are you still allowed to push stuff to it, or are they like, no, Bjorn, stay away from this stuff? What does that look like?
I'm not allowed to code anymore. I find side projects because part of the problem is I really enjoy my role. I spend a lot of time being in front of customers and prospects because I love it. And I think founders should be in front of customers. If you're not in front of customers, you're doing it wrong because this is how you get the feedback. I get to see how people use our product. I was just visiting one of our customers last week on site. They do cryo-EM, so they have those crazy electron microscopes. And I learn about what they do. It's so exciting, And then I take the feedback and go back to our engineers, to our product management, and say, okay, this is what I see. And I have the engineer perspective, but I also now have the customer's perspective. So that part I absolutely love. Or, when you talk to prospects and you see, where are we good fit? Or you learn, where aren't we good fit? What is missing? Why do they go with our competitors? You learn from failures, often more than from your success. So that part is super exciting. The downside is that I'm not allowed to code anymore. I tried, but our engineers were not very nice. It was like, the code review was like, nope, this is bad, this is bad, this is bad. And then I got the message on chat that it would be better if I focused more on other things. So I have to find like little side projects. I wrote a tool that distributed system, when you do debugging, you have log files from a lot of machines and you're trying to puzzle together what happened when. So I wrote a log merge tool in Python that can read the timestamps and then highlights it in the terminal in different colors. So those kind of things. It's a bit sad, but when your job is to run a company and focus on those things, and I also had to learn a lot about marketing, for example, coding, I would love to do more coding.
And don't get me wrong, I will defend you till the end of the day that, like, it's always about, feedback. I'm sure they're playfully saying that you can't touch the code anymore, but the tools that you're talking about, like, I am a geek about building, like, command line tools or any kind of, like, tools that plug into software. I got into this whole, like, I like Golang. Somehow I kind of picked it up a couple of years ago, like 5 years ago, whatever, and, like, every time I get the opportunity, I build command line apps with Golang. That's kind of one of my outlets. So I can kind of see how you kind of have, if you have your main role as somebody who is like really expanding the business and talking to prospective people, but then you also have this itch of like always building stuff on the side. I could definitely relate to you on that one. Maybe I want to ask this in terms of, you love talking to people, and I can hear this in terms of talking about your product, but also understanding their problems and everything. When I talk to people in that role, in that position, do you get to choose who you talk to? And this is an interesting question, because in the sense of the people, the decision maker that usually allow this partnership maybe are not in the tech world, or maybe somebody from like the accounting world, maybe some higher level like CFO or whatever. So for me to maybe ask you from your experience, because you do encounter this way more than anybody else, at least more than I do, is who do you get the chance to talk to? Do you get to talk to the IT department directly because they're the one that understands this feature, or do you end up in a lot of meetings with like whether it's account managers or anything like that? I love asking this perspective of how you approach this, because I'm assuming you have some ways of tackling them.
Yeah, the good thing is that because I'm a founder, I can define my role to some degree. So when I'm in front of customers, my role is the role of a techie. So I'm doing the tech sales. I'm talking to the IT admins, to CIO, or head of infrastructure, the people that understand technology, and I sell the technology to them. For everything that's then more on the financial side, like negotiations, contracts, the not so nice part of sales, I have my sales team. Great people. I love working with them, but I'm also so happy that I'm just not good at haggling for prices, because sometimes, I learned a lot about that. It's not what I want to do. So I have the luxury of, as a founder, to focus on the technology part, and also tell customers when they want to talk to me about, the business side, I hand that off to the sales team. I'm a techie. I love being a techie. So
it's the same aspect of leveraging your strength. And don't get me wrong, you have absolute strength to do all of it. But when you leverage like the extra bump in that bubble, that extra PhD in you of like being an expert, of tech and everything, it's good to leverage that more than anything. And yeah, the haggling part, the debating what prices it is always it's a game of chicken. The first person to pull out, that's usually how that works, if I got
Yep.
that correctly. But
Yeah, and then I think as a founder you always have the problem that it's your baby. So you're kind of biased. So this is why it's good that I can focus on the technology part. And it's also, I would say, the more fun part, because I get to see the customers' use cases and problems. And we have customers that, life sciences, machine learning, autonomous driving, media and entertainment, research. So it's such a variety, and that, I think this is the coolest part of my job, that they tell me about what they do, their work, their product, and it's just so exciting.
yeah, and obviously I'm glad that you get to do this. It's a keep on going journey. It's a journey that keeps on going, and the fact that a lot of engineers at the end of the day, sometimes we just don't like talking to people. But then there's also the, I guess, like, not the outliers, but the people that do end up having a really strong tech background and enjoy talking to people. You're a breathing example of it, and I think that's absolutely cool to think about more than anything. But when we're talking about this role, this co-founder and CEO of Quobyte, how do you make sure things run smoothly? How do you make sure that, like, you have an understanding of what happens when? And the way I ask this question a lot is, what tech, what app, what tell me what app, like, do you have a favorite app on your phone? Do you have, like, favorite app that you use between your teams, that you communicate and everything? Like, your day to day, what helps you what helps you do your job, in terms of technology and apps and all that kind of stuff?
I would say my favorite app or most used app is probably the different messengers, mostly Google Chat that we use internally, and stuff like Signal, because communication is key. Talking to the people, head of marketing, talking to my co-founder, who's our CTO, as I mentioned, bringing back the ideas from the customers, talking with the sales team, talking to our support people, what's going on? Is there a problem with this POC? So understand, communication. I think that's probably that I spend a lot of time on. And as a coder, it's sometimes weird because it feels like you're not getting stuff done. You're not doing work when you're actually doing a lot of work, but it's all talking. That's something I was initially struggling with. And then the second most used app is probably email, which also falls into that part.
That's totally fair. And maybe I could ask this one is, do you use any note-taking apps? I know some people are quite fans of whether it's Evernote or even the iOS Notes app. Like, is there any structure that you give yourself? Like a mini, daily log or anything?
Task list. My daily log is more or less my calendar. So I have calendar entries for a lot of stuff. Because, I think it's, I try to use just a few apps like email. Email to some degree also ties into my inbox is my to-do list to some degree, and then I have a to-do list. Some people like to text, but that's like a black hole. If you text me, I read it, and if it's something that I can't answer immediately, it will just go because it's not an email that is unread. So I think that email and calendar and the built-in to-do list, that's how I structure myself. Plus then there are things like, a CRM system for where you have the notes. So this is where I take notes for when you talk to prospects and customers, what's happening there.
I love that you're sharing all this, because I do share a lot of my processes at the end. Because, like, if I think about thinking so much about tech, right? Like tech, all the GitHubs and all CRs and all that kind of stuff, that's one part of the world. But the other part of being able to live a dream of running a business and talking to so many people is that you need other tools to help you manage your day-to-day time. I know people that, like, they're massive. They use the task feature on Google Calendar, so they put, like, all their tasks in it and, like, they just check it off. Or even, like, people on Slack, they just do /remind and they type them something to themselves and it just reminds them in a bit. So those are all fun trick to hear from me, from you, just because it helps you be who you are. It helps you be Bjorn.
Yeah, and the problem is when you're a co-founder, you wear many hats, and there's always something that's falling off your list. So it's basically you have to have the to-do lists where you also consciously push stuff off and say, this is not going to happen, or they didn't ask in 24 hours, so it can't be that important, so remove it off the list.
it sounds easy, but it's not. I agree with you. It sounds like it's super easy, but at the end of the day, if you're not able to do that, you're spending so much time going into a rabbit hole that has nothing that will progress what you're trying to do. And that's probably not ideal if you're, running a tight ship, which a lot of people are at the end of the day. I will ask this question, but I've been fascinated by this, is ExtremeFS, Fleece, BabuDB, FAT Lease. Who comes up with these names? And the reason I mention this, because these are all like stuff that you've researched and you look into this, published documentations on that. So this naming system, this etymology world, what can you share about this in the sense of where they come from and a little bit of story behind those?
So extreme FS is easy. Someone, and I don't know who gets the credit for that, came up with Extreme OS as a name for this project when it was a huge EU-funded project. And we were part of that, so we made it Extreme FS. So that was someone else who deserves the credit for that. Then fat lease, I think there was fault-tolerant leases, and then, fat lease. And then we had the improved version, which was, we looked for a different name, and it was a coworker, Minor, that's his name, Minor Gordon. He deserves credit for fleas, because it sounds, like fleas, like something soft, but also like fleas, a lot of those tiny, nasty bugs everywhere. So it was kind of play on words. Him being a native speaker, American, he had a huge advantage there. So he came up with that. And then BabuDB, that actually came from the technology. So we implemented a LSM tree database. Usually databases are B trees. That's how you build classic databases. And then someone came up with the idea of so-called log structured merge trees or something like that. I think that's the name. It's a different way of doing things. And you basically have, instead of, changing an index, you make them immutable and create a new one and a new one and a new one. And it's like, and then we were like, oh, that's like, in German we call them babushkas, which is wrong. I think they're called matrushkas, those Russian dolls, where you stack it inside out because you basically have to go through all layers. And then that's how we came up with babushka, BabuDB. PhD students sitting in a room having too much time, being weird. Sometimes you work until 10 p.m. Because you just want to solve that problem, and then you get silly. I think it was one of those evenings.
It's taking naming a variable to the next level, right? Like naming a product, naming a technology to the next level. And those are all good examples, and you have countless of them. So I encourage everybody to check out any. I'll try to link as much as I can, because this is something that is so cool to hear about, a story to hear about more than anything.
Yeah, we had to we had to get more serious when we created a product, of course. But in ExtremeFS, there were, I don't even remember. I think the RPC server was called Pinky, and then we had the database called Brain. So you integrate all of your favorite cartoon characters and stuff. Again, when you're in research, you can do all kinds of weird shit.
Hey, who knows? Maybe you may have way more behind the scenes like Quobyte that we know about. But either way, I love these Easter eggs, all this kind of fun stuff behind it. So, the last question I do have for you is, what advice do you have for people from, whether from the academic background or working in corporate world and trying to, take everything you've learned and put into a dream, into a company, into something that you want to build? Do you have any kind of like succinct advice for people to do it, whether you're talking to Perry or anybody, or even things that people should not do, which is always the hard part to think about? What do you have to say or think about that?
Yeah, I think looking back, I had the typical techie arrogance about things like sales and marketing. Technology is great and whatever, of course. But that you need great people for those fields that you don't understand. You need someone to complement you. And the other thing I learned, I spent a lot of time learning more about marketing myself, because in the end, you have to understand it a bit. As a co-founder, if you rely on other people, unless you trust them 100%, like, it's someone, you have a co-founder that has this kind of background, you have to learn a lot yourself around how marketing works, how lead gen works, what doesn't work, and it's also a lot of experimentation. So I have gained appreciation for both of them, because they're kind of like, they're kind of an art. There's a bit of structure there, but it's also an art. And if you plan to start a company, you should plan on immersing yourself in sales and marketing.
That's amazing. And I just want to give a shout out to you and Quobyte for pushing that barrier of, hey, why don't we start a YouTube channel? Why don't we start a GitHub and use all those channels? Because that's something that you guys do at the moment in terms of trying to get the knowledge out there. Whether it's for prospective clients or existing users, you have a lot of good resources on your website. So maybe if you have a couple seconds, like where could people find Quobyte and where could people find more stuff about you, Bjorn? Because I do know you've gotten featured into different talks and I really do enjoy those as well. So
I guess I am somehow on our YouTube channel. I know there are some video interviews, or you can find me at mostly at supercomputing conferences. So if you go to, I'll be at ISC in Hamburg, and then I'll be at supercomputing. I think this year it's in Atlanta. So this is where you can always find me. And then Quobyte, it's easy. As I said, we have the free edition. So if you have hardware, or if we also you can run on the cloud. The best thing is we can talk about it all the time. Proof is in the pudding. Just download it and use it for yourself, because I think that's, like most techies like to learn about something. Get the hands on it and just try it. Why not?
And of course, all the links will be shared in the description notes below, so definitely do check them out over there. But I mean, this has been an absolute pleasure on my end, and I speak for hopefully everybody that I've learned a lot on this conversation, and your stories are just sometimes so funny that I really, really enjoyed talking to you on this. So, Bjorn, thank you so much again for being on the show.
Yeah, this was fun.
And I will catch all of you on the next one. And that was Björn Kolbeck, co-founder and CEO of Quobyte. All the links are shared in the description notes below. Go check them out. If you would like to be on Podcast Room by a Software Engineer, reach out to us. Just email contact@perrytiu.com. Can't wait to have you on the show. Once again, thank you so much for listening to Podcast Room by a Software Engineer. Don't forget to hit the follow button on your podcast app and leave us a review on Spotify and Apple Podcasts. It's completely free. And if you want to tell your friends about Podcast Room by a Software Engineer, that's totally cool as well. Anyways, I am Perry Tiu, and I'll catch you on the next one. Big love.